Good afternoon, YouTube. It's Sean Parker with Geomagic again, back for episode 3 of our deep dives, again looking at Geomagic Design X and a part that has frankly been beaten to death by us. This has kind of become our standard demo part over the past couple of years here. Um, and just about everything has been showcased on, other channels. Greg George, for example, has got a good series of videos using this file. Even our own kind of marketing team has used this part for a number of purposes. So normally speaking, I wouldn't bother showing this because I like to show more interesting files. But I actually did have a user request, somebody that watched one of my previous videos, and they noticed that when we model the gas valve from scan data, we tend to focus on the outside of it and almost never focus on the inside of it. And there's kind of some tricky geometry in there, and so he asked if I would be willing to show some alternate or some methodologies for working with the interior portion of the scan. And I thought about it for a minute, and I figured it would actually make pretty decent video content for a couple of reasons. One is these threaded areas here are something that kind of get glossed over in a lot of cases, in the reverse engineering within Design X. And there's a good couple of reasons for that, which I'll get into in a bit. Um, and the other thing that I thought was interesting is, one of my favorite things about Design X is its ability to work with incomplete scan data. And if you have any experience with 3D scanning, and I would kind of assume that you do if you're watching this video, this channel, um, you'll know that it's fairly difficult to get a fully watertight scan of an object, especially one that has, interior pockets and holes and stuff like that, that it's difficult to get line of sight into. Most scanners that we work with, the white light systems, the laser systems, etc., they all require some kind of line of sight so that a emitter of a laser or a light or something like that and a receiver, a camera, sensor, something like that, can both see the same part of the object at the same time. Otherwise, you can't get a return, you can't get scan data in that area. And in a lot of 3D scanning software, especially reverse engineering software, that's not an easy thing to deal with. Trying to figure out how to fill holes and work with other areas is generally going to be fairly difficult. And a lot of those software packages do require something near a watertight mesh in order to generate a solid body model from it. DesignX is a little bit different though, since we use the same feature-based modeling approach that SolidWorks and all the other major CAD packages use. There's kind of a ability for an operator to add CAD features in, um, either using partial scan data in an area or just eyeballing it, which I don't really want to, suggest. But in reality, there's a lot of reasons where I might be able to place a sketch on something that doesn't have any scan data to drive that feature necessarily, but I could take measurements from a tape measure, pair of calipers, a dial indicator, something like that, and blend that knowledge plus the knowledge that I just have in my head or from having, holding the part in my hands to fill in any gaps that may exist. So we're looking at a, scan of the gas valve here. This is actual real scan data, unlike a lot of what, everybody in the 3D scanning industry shows, which is kind of falsified scan data or something that's been really polished up ahead of time to make for a really good demo. This is mostly raw scan data. I believe this came from one of our capture scanners that we discontinued a couple years ago. It's a white light scanner, it's a tabletop scanner that has a turntable with it. Very similar to some of the Ein scans, um, from Shining 3D all the way up to the GOM scanners, the ATOS series, etc. Um, and being something that's not like handheld, it does tend to be a little bit more difficult with some of those things to orient the part and the scanner in such a way that the entire certainly interior can be covered. General rule of thumb that we use in the 3D scanning industry is that you can collect 3D scan data about as far into a hole or a pocket or whatever it may be, as that hole or pocket is in diameter or just the largest dimension on that feature. So, for example, in this case here, I've got a hole in the center of this part that is, well, let's use one of Design X's measurement tools here just to kind of estimate it. Across, we're looking at, yeah, maybe not quite a full inch, so 85 or 850 thou, give or take. And you can see that, obviously all of the blue or this teal color here or whatever indicates that I'm looking at the back side of a triangle. So in this case, I'm just looking at the alternative face here. By the way, for those of you that use Design X on a regular basis, we can turn off back face view. So I can only see triangles that are pointing at me, and I can even change the color of them. So if I want it to be the same color on both sides, I can use as is. I can even user define my color just to make it a little bit more obvious for me. So what I wanted to show, just to kind of prove a point a little bit here, that diameter there is not quite an inch. And so I expect the value from the deepest triangle in this hole to the edge or so up here to be in the ballpark, same ballpark. That's actually a little bit deeper, so you can see that somebody was able to, get a decent angle. Whoever scanned this was able to get a decent angle and collect a sizable amount of data down there in this cylinder. But once we get to where we expect this hole to interface with this threaded portion on the outside here, we're missing a ton of data that we're going to have to figure out how to model in using other techniques. So by the way, you'll notice that my 3D scan here, my mesh is pink, and you might be wondering why. Well, there's no reason for it, other than when I was looking for this, I wanted to use real scan data. I've got so many 3D scans of 3D printed versions of this model that I wanted to use the original that had the threads still in them. And so I imported like 5 other meshes before I was able to find this one. This one happens to be, and so DesignX assigns colors to meshes as they come into the software. If you do want to change the color of your mesh for whatever reason, another kind of hidden option inside of we're in the display tab over here, is that I can select an object and actually go not to the display tab. I misspoke there, to the properties tab where I can see my material here. You can see that that color in this box is analogous to what you see on the screen. And if I wanted to change that back to the standard default blue, just click here and hit OK. And so you'll see that the first mesh that gets imported is going to be given this blue color. Green, yellow, pink is where I was before, so that was the 4th scan that I imported, and it'll just keep going down this list as you add new scans to this. And if you want to change them all to a single color, you certainly can. Here you can also change the transparency of an object too. This is one way of doing this, kind of a permanent transparency for a mesh. There's also a way to do it in a more temporary sense if you wanted to use, again, back in the display tab here, there is a transparency box that you can select, and you can choose what types of objects are transparent, which makes it really, really nice to be able to kind of see internal stuff. If you're working with CT data, especially this feature might be kind of useful to you, but also, like anything else with Design X, you're working with meshes and maybe point clouds and surface bodies and reference geometry and solid bodies. And there's just so much to see on the screen that sometimes it helps to, clip things out, either using the view clip like we've probably shown before on this channel, or using the transparency features. So anyways, that's all that stuff aside. What we want to discuss today, as I mentioned, is how to kind of model some of this internal feature here. What can we do when we're missing scan data? And since I haven't really talked about it in great detail before, how do we model threads? And when might we, I can't speak today, when might we want to model threads in Geomagic Design X? So let's get into it. Now, I've started this model already, so you can see I've got plenty of history in my history tree here, and I've modeled the majority of the exterior. I haven't quite finished the top portion of this out, and maybe missing a couple fillets and some other features, but for the most part, I've got the basic body already built here. My job now is to figure out how to remove some of the material on the inside and make this an actual functioning gas valve. So to do that, I'm going to start with some of the basics on the inside here. Uh, it's pretty trivial to cut out some areas and add some new areas in here. So I'll kind of speed through some of that, and if I encounter anything really all that interesting, I'll let you guys, or I'll kind of come back in with voiceover. But I'll start with just a couple of features. I'm going to punch out this main bore. I'm going to make sure that I trim my cut with this plane here, which I can either extract from the scan data, or since I've already kind of built that plane on the top here of this surface, I might just reuse that with an offset, but we'll see how accurate that is before I commit to that design choice. I assume the design intent of this is to be a uniform thickness, something with that top surface, but the accuracy analyzer never lies to us, so we can make sure that that design decision is actually worthwhile. So let's go ahead and create this sketch real quick. I'm going to build it on my right plane. Really simple, quick offset, find this guy. And just since I'm in this tool here, and something that I talked about a little bit in my last deep dive, which is the mesh sketch setup. Um, if I click on, for whatever reason, Design X has figured out that this radius for this hole is actually three slightly different radii for some reason. I'm not really sure why. We can play with some of the sensitivity for that. But that really only matters for the auto sketch. If I fit a circle to it, I can choose as many profiles as I want, and it'll average all of them into a circle. Of course, I can also move the center point to my origin there, and when I do that, it becomes a fixed blue color. Um, if I choose to use the auto sketch instead, though, um, and select all 3 or 4 of those things there, I am going to get a disjoint circle. So that's one slight disadvantage to the auto sketch. Uh, if I were to try and average one circle between multiple features there, it looks kind of like this ovals out a little bit. I'm not really sure why. But let's fit a single circle to it, maybe figure out what's going on in this area deviation wise. So again, the accuracy analyzer is also available to us in 2D mode. And if I expand this out, I can see where my max deviation is. And I'm only working with about 7/8 thou there. I'm not really too concerned about it. So we'll go ahead and build that sketch. We'll also take a look and see if we do a surface offset of that surface. Turn off my solid body there, turn on my mesh, and there's no estimate button for this surface offset like there are, for the Fillet or Chamfer or some other tools. So unfortunately, we're going to kind of have to do a guess and check here, but we do have the accuracy analyzer that works for us. Problem is, the accuracy analyzer by default is using the normal vector of the surface and the mesh to figure out the distance calculation and therefore the color. If I offset this, I don't even know, I'm going to guess, let's say 1/8 of an inch, right? It's going to go in the wrong direction, first of all, so I'll flip it so it's going inside of the part, and I'm seeing a pretty substantial amount of deviation here. And it's all about the same amount, unfortunately, as my offset there. So about a 1/8 of an inch offset. All this deviation value here, this blue, is all right at that 0.125 value, which means that it's not actually looking at because the surface is being offset, it's pointing the same direction as the other one, and the accuracy analyzer is not recognizing that. Now, what I can try and do, I don't know what my max angle is allowed to be here, but I wonder if I can put 180 degrees into it. No, it only looks 490. So we're kind of stuck, unfortunately. I can't really use the accuracy analyzer in preview mode. What I need to do is I need to exit if I want to try and get a nice, decent accuracy, offset, or at least test to see if the surface offset method is valid. I'm going to need to flip the normal of that surface. Now you can see I'm seeing the front of the surface, essentially the top of it, the positive side of it, which is indicated by that yellow color. And now when I use the accuracy analyzer there, I actually get, my surface is high, and it's high by 40 or so thou, 40, 45 thou. So if I come back into my verse normal now, oh, no, sorry, the surface offset rather, and I say it was 40 thou off, so we should be in the 0.8, oh, 0.08 range, exit, and the accuracy analyzer now, since the surface is facing properly, gives me, a couple thou deviation there. And it's uniform across the whole part. There's a couple of splotches here and there, which may be embossings or casting defects or something. So I'm going to leave it as is and be fairly happy with that. Now, one thing I do know is that this surface does need to be um, large enough that it intersects the hole that I'm building here. So I need to do surface extend on it, keep it linear or same surface, doesn't really matter since it is a plane. And you'll notice that I can't really drag this out because eventually I get some geometry constraints here that, since I've already, modeled a bunch of that surface above, or other features there, I can't offset everything here. So instead of doing this right now, what I'm going to do is I'm going to move this surface offset up in the feature tree before that. Let's see, what is it that's cutting into that, like this cylinder or whatever was built, so that I just have like a single surface here. And I don't know where that is, so I'm just going to roll back through my history tree and see how I built the beginning portion of the model here. Nope, maybe just a little bit more. Yes, okay, so this is a good time to put it in because this is before this cylinder and this feature got merged together. So let me find that surface offset and probably roll to the end here. And I'm going to move it up there. Now you'll see, if I hide the solid, I don't have that notch in this thing anymore. The surface offset was moved to reference that surface before it was made more disjoint, but that extend still works on it. And now if I go here, view normal to this, I want to make sure that the surface is bigger than this circle sketch that I created. And now what I can do is extrude that sketch up to that surface and cut the solid body out inside. And that was a fair amount of work to get to this. There's other ways we could have certainly modeled that, but that is one valid way of doing it. Another problem that I just noticed, though, is probably should have did the offset with that fillet too, because now I cut into the fillet. So instead of cutting, I think the way that I'm going to fix this is I'm just going to build a new body. And before I cut this away, I'll go ahead and add a fillet here. This estimate will work, and that's just filleting an entirely new solid body that sits inside of this existing solid body. And now I'll use the Boolean cut command to cut my tool body away from my target body. And now I have more or less a hollowed out area there. I probably could have used the shell command to do something similar, but that's maybe not. Maybe with some of these other features here that would have gotten in the way. So I made that probably a bit more complicated than I anticipated. I talked about it a little bit more than I anticipated, but overall, at the end of the day, we are done. So it's now time to start adding some of the features in. So I'm going to start again with something fairly basic. It looks like this cylinder here. If I go into my polygons tab, I can make it obvious what I'm talking about. This cylinder here looks like it can be modeled as a straight cylinder, or maybe it's a cone, probably a cylinder, that cuts off right just to the right of my top plane here, and it gets filleted in with the rest of the body. Now, there's a massive gap missing data in this place where it's just too difficult to be able to get scan data down there. So we have to make the assumption that this feature goes and just stops at this point, but we can also have to make an assumption of what the other feature, this guy, looks like as it hits the bottom. So I can see a more or less continuous fillet down here to fillet these two features together, and we can use the radius of that to help us estimate what the real fillet is in real life. I can also see that it looks like right here there's another fillet feature to this little tab or dimple or other kind of cylinder thing that intersects with this cylinder. And so we can model that. And then there's more missing data down here, so we'll have to figure out uh, using some intuition and how to fill in the blanks in that area. So let's start with this first feature here. I'm going to build my model tab, click on this top plane. If I right click in space, I can get the context menu and access the mesh sketch really quickly. And what I want to do is actually offset this thing way into the part here so that I can get a more continuous or just more data to create this cross section. So just missing wherever that hole basically starts. Hit OK, go in, and need to remember which one of these features I am modeling. This is stuff that I don't care about because that's on the top of the model. Go ahead and just build a circle between that and this to average it out. Hit OK. And then we'll go ahead and extrude. Oops. I'm going to go up to the surface, this surface in one direction, and we're going to go in the opposite direction. Now, do we have a region that we can work with there? Possibly. Right on the end here. Not really. Not exactly. So we do have regions on the scan there. It's just not really all that simple to use them. One thing that we can do though uh, is go up to region, and instead of what I was hoping for, would there be a tiny little plane in here. What I think I'm going to have to use instead is a max distance position where I select like this cylinder here. And you can see that using the direction of the extrusion, it's going to find the furthest triangle to the right and build my extrusion there. And I think I'm happy with that. Once I add some fillets in, it's going to look appropriate. This side, though, is not identical, so it's not a perfect match. I'm going to go with it, though, but I may, there may be a reason, depending on the accuracy that you need, to create like an extreme position plane from this region in the direction of travel of the extrusion and that region, then maybe averaging them out depending on how you want to model this thing. But I'm going to go with it as is right now and see how that looks. And also make sure that I don't do something stupid like this, where it looks like the circle that I just built is actually a continuation of the same cylinder here. So I probably could have modeled this in a different way, but as we always say, there's multiple ways to skin a cat in CAD modeling. There's always different approaches that everybody, with their level of experience or whatever is going to use. There's no right or wrong way to do CAD modeling. That's probably a wrong way. I'm sure that SolidWorks professors or whatever would maybe disagree with me. But so how I'm going to fix this here is I'm going to change this sketch from a full circle, understanding that I already have this stuff up above, and I'm just going to create a line. Um, maybe not, maybe a little bit more than halfway through. We'll extend it and then trim away the rest. And that should solve that problem. As long as that line is inside of the part and above this surface, so we don't have some weird gap in there. It doesn't look like we do. So there's one feature. Um, I'm going to model this guy slightly differently. And actually, I think I'm just going to be lazy. It's good, clean scan data. White light data generally is. So instead of sketching it myself, I'm just going to let the Revolution Wizard do my work for me. I am going to need to modify this sketch a little bit, but it's a lot easier to let the software do the majority of work for you if you can. Um, and that should be good. Let's see what we get here. Might want to tweak the sketch a little bit. Actually, fairly happy with that. and let the software just build that sketch and that extrude from us, or revolve rather. The sketch I do want to build a little bit bigger because I want it to go into the model a little bit more. Let's see if that makes for some interesting geometry. Oops. Broke the revolve. How did I break the revolve? Usually that means that I created a disjoint endpoint somewhere, but the only two that I'm seeing here are these ones. So if we're going to be live transferring this to any other CAD package later on down the line, it's probably in our best interest to convert this away from construction geometry, and then we can corner trim everything back together, and we're looking good. Although I don't know if this is truly valid. Actually, I think that is good. What I want to do is um, I am going to come punch the hole, the center hole out of this later, but right now I'll just kind of throw that off into no man's land. I do want to fix this though. So I build this here, and then I of course have to modify all the rest of this stuff back into position. Probably should have fixed it before I moved that thing. Let's actually do that. I like where you are, and I like where you are. I just want you to be horizontal, and we'll add those fillets in later. So that's that feature built. We'll keep going because there's one more thing that I need to build down here, and then we can start filleting everything together. And after that, actually, there's two more features because there's these interior dimples too, and then we can attack the threads as the last thing that we do. So in this case, I'm just going to put a sketch right on this plane. I don't always recommend that sketching on regions, depending on what type of modeling you're doing. It may be, you know, more as-built modeling. That's generally acceptable. What I don't like about doing that with, kind of design intent modeling is that there's no way that this plane, this region, the best fit plane to that region on the mesh is going to be, analytically, mathematically, perfectly square with some of my X, Y, Z, front, right, top planes. Um, or, yeah, my axes here. So instead, what I recommend doing instead of just sketching directly onto the region, what we can do is we can build a plane on it. Oops, different tool. There we go. So I'm going to select the region. I'm going to use the extract tool, which is basically our best fitting algorithm to build a plane off of that region, which also knows that it's already a plane. But what I'm going to do here is I'm going to say, give me an axis constraint and use the specified direction. This is going to be the normal direction for this plane as it is. And I want to make sure that I'm using the X direction here because that is the one that is going to be, perpendicular to this plane. So if I choose X and then hit preview, you can see that it's going to be able to use the majority of that data there. It filters out some of it because I do have outlier removal on, but it's going to build a plane that references that region, but forces it to be perfectly parallel with one of my existing system planes. Okay, so then I'll do my sketch on that. And I'm going to turn off the regions here just to make it a little bit more obvious here. I'm missing a lot of data. And so the best thing that I can do in this case is put my sketch right on the boundary of the mesh where it stops, right where it cuts off. And I can't really do that with my normal offset tool, right? So in the last video, the deep dives about mesh sketch setup and stuff like that, we talked about the silhouette range. And the silhouette is the other arrow that's on here. By the way, if I shrink this thing down, I can kind of focus just on that one area that I'm interested in. This is useful for a lot of things, especially draft angle calculation, because you can let the software ignore parts of your mesh that don't have the draft that you're trying to analyze on it. In this case, we don't really care. It's just nice to keep both of the arrows a little bit closer to one another. So if I drag that arrow up, or again, if I add, a value to this silhouette range here, so that it encompasses a little bit of that, or basically the volume of this mesh sketch slice here interfaces with this feature, then I can see that exterior portion there. It ignores the fillet, and it gives me the maximum that the scan data tells me to do. So when I go into sketch mode, not the cleanest cross section, but let's see what happens when I fit a circle to it. It's going to be a couple high and low areas, and that's to be assumed. If I want to try and do some full definition for this sketch, I can of course create a construction line to the origin, make it vertical so that it's directly on the center line or the plane or whatever it is there. And then of course, once I best fit a value, if I put a dimension on it, then I can see, well, maybe the original designer's intent was to create a, I don't know, 0.325 fractional. That's probably way too big, but I can choose what value I want to put in there, even though I'm not using perfect data. But if that's close, I know that there's probably going to be just a little bit, the real feature there is going to be just a little bit bigger than this currently is, because that feature cuts off on the fillet. So maybe if 0.325 looks right, and it looks like it kind of lines up at least on the cutoff of the mesh boundary down here, maybe I leave it at that, and then use my own kind of design intuition and knowledge and uh, dimensioning, thoughts or whatever to add a dimension that is more relevant for this feature. I'm going to leave it there. That looks good. So we can go ahead and make sure that that is now extruded and merged down to that surface there. Or we can just say up to body in the opposite direction. That's what I want. Okay. So there's all of that. And I'm going to take a quick break here and come back, and we'll wrap this up, cut some holes, punch some holes out of this thing, and add some threads and call it a day. So let's finish this up now. We've got a couple features left that we want to build. Easiest of the 2 or 3 that we have remaining probably are just these little guys on the side wall here. And again, they're not complete features. We are missing some scan data, but nothing terribly concerning, hard to worry about or whatever. And we're going to use the same, similar method to what we use down here. So again, using the reference plane tool, and should default to extract if I click a region, but I didn't have my regions shown. So there's that region, and again, we're going to fix the axis constraint this time to Z, which it's already set up for. So with the preview, that plane looks good. And we're just going to model one of these things and then mirror it. Obviously, try and do patterns, save us a little bit of time. So get my cross section set about where I want it. Try and make sure that it's right between those 2 fillets, since this is a fairly thin, skinny part. That looks good. Auto sketch works great in these circumstances, and I just want to make sure that this does live inside of the rest of the CAD body somewhere. Corner trim everything together, and just like before, and actually looks like I need to clean up an area here. Must have been this cylinder here. With this feature, just like we had to kind of do the Boolean to remove this larger area here, we can't pattern or mirror features inside of Design X. I know SolidWorks and some other CAD modeling programs can. We actually can only do bodies in this software. So what I need to do here is I need to obviously extrude this sketch up to that surface the other way, but not merge it, creating a individual body. That's fairly annoying. Let's see if I can change that. Maybe up to body is a better idea. Yeah, that's not gonna interfere with anything. That's a little bit better. I might try that on this other cylinder here. But first, let's go ahead and mirror that about symmetry plane there. Should be able to do, could be able to do trim and merge. That's usually a surface operation though. So we'll just do Boolean merging all three of these bodies together. And that's complete. I do need to go take a check back with this feature. And what's nice is if you click on a face or whatever in the software, there is the feature tree will skip back in time to it, so it's easy to find the feature that created it. Let's see. Since I modeled this with a revolve, this may be a little bit tricky to get right or to modify back to where it's supposed to be here. Let's see if I can just push this up just a touch and if that makes any difference. But I also do want to make sure that I am going all the way down to this surface with that. So easy way of checking is, can we fillet this? And the answer is no. So I need to make a couple of tweaks in here. With my modeling philosophy, it may just be better to model this with an extrusion. And I'm also having similar issues back here. So I'm going to just make it a little bit easier for myself by doing a view clip, because I want to make sure that there's no gaps or any weirdness at the bottom here. It's just really difficult to do that without clipping, adding a clipping plane here. And let's actually clip on a real plane just to not get these weird goofy angles. So now I can see kind of what's going on a little bit better. So I want to make sure that this circle or cylinder goes all the way out. So what I'm actually going to do is, instead of editing this feature here, I'm just going to disable it or suppress it in the feature tree. And the reason for that is because I already know, I built this thing earlier. So we did a little bit of reshuffling beforehand as well. And so I may want to move this down if I can. This might be a little on the tricky side, but if I can move it down to after the point in which I cut this out here, which was one of the first Booleans that I should have, which is this guy. So I'm wondering if I can, if the history tree is going to let me drag. Nope, I've got one child entity, which is that chamfer, which makes sense. So I actually need to move both of these features down now below something, and it's not letting me do it. Oh, that's fillet actually is also something. So let's see if I can move all of that down below the cut. Oops. Just below the cut is where we need it. There we go. And so I've rearranged the feature tree there, right? And allowed for this cylinder to exist after cutting this area out. So if I turn off my view clip now, it's not perfect, which is fine. There's a couple things that I can do to fix this. One of them is just probably making it a little bit easier on myself so that I don't pull the whole cylinder back here, because I still do want it to blend in top, with the top surface just fine. But what we can do is use the move face command, push this face in this direction, and if I preview where my mesh is here, I should be able to see, or flip that all the way back here. So let's align our viewpoint and get that feature in the correct location for where we want it, which is about there. And voila. Now we do need to modify this feature as well. Or probably the easier thing to do is just let the revolve that creates it move down this list a little bit. So all of these features here, maybe I just put them at the bottom. There goes that. And where did that last, this guy, Extrude? I want to move him down too. This is the byproduct doing something the first time. It's been a long time since I've modeled the inside of this thing. I wanted to point out a couple of things in this video. So, having a little bit more knowledge of some of the more advanced features, the less used features in the software, which is kind of the point of this video series anyways, has allowed me to make some corrections without really having to delete anything and redo work. So that's fairly nice. I can still get the result that I'm looking for here, just moving things around, realizing that I maybe didn't have the perfect approach, at least at the beginning, and was still able to get to the point where I'm fairly happy with this, other than, a couple of fillets and a couple of other things, and obviously the remainder of these holes that I need to punch out of here. So let's do that. We'll switch gears now, I guess, to well, let's, yeah, I'm gonna probably wait to punch this hole out last, since there is no scan data in here at all to speak of to tell me how deep that hole goes. I think what I'm gonna do, looking at this part, it looks like this interior hole basically blends in fairly well with um, within it, rather, this is a smaller diameter hole, and the software actually says it's a cone rather than a cylinder, so it looks like it tapers a little bit as it blends in with the kind of longitudinal hole here. So let's work on those first, and with that, then we get to start talking about helixes and doing threads. Now, threads in most CAD software, as most of you are probably familiar with, are usually just visual threads, right? They're graphical threads. They're not actual geometric threads. And there's a couple of reasons for that. One is it's just much easier to render. And two, most CAD packages, SolidWorks, NX, Creo, CATIA, etc., have libraries of, standard ANSI threads and whatever other metric threads. Um, in Design X, we don't have that. Any of those libraries would just add, additional gigabytes to the already quite large installer for Design X. So we can create threads in this software if we want to. And there's some cases where we may actually need those threads. Like if we're going to go directly to 3D printing from this, we may want to just manually make some threads that are functional threads for the manufactured part. Or if we're not going, through live transfer or anything like that, through a CAD system, we're going directly into manufacturing, it may be worth having some threads, some actual threads on the part. It is a little bit of a challenge in Design X, but not terribly difficult if you have a couple of best practices in mind. So we'll go ahead and do it on this here, and I've got more than enough thread data to kind of tell me where everything sits. So uh, one thing that I'll start by doing, obviously, is just cutting the hole out. And what I'm going to do is I'm going to cut the minimum diameter hole out here. So just at the high point of these threads is what I'm going to use for my sketch for the cylinder that I punch out. And what I'm going to do is place that sketch on this face here. And again, this is another time that silhouette tool comes in a lot of handy, because as I drag this offset into these threads here, obviously these threads are on a helix, so finding the high point of each one of those threads is not going to be easy. At least certainly not all the way around, right? That cross section is going to be in the low spot on the top, the high spot on the bottom. So again, that silhouette is just going to find the minimum diameter of that hole with the threads in it, and allow me to very quickly sketch circle off of it. Again, I could put some constraints in here to lock that feature in position, but for the purpose of this video, we're not needing to do that necessarily. And then I'll go ahead and extrude, cut, and let's see, which side did I start on here? I started on probably the easier of the sides. So we'll go ahead and, since we've just got some space here, I'll go ahead and just do a blind extrusion to cut that out. And actually, since we're kind of 100%ing this thing, I did miss a feature here. So let's go ahead and model this before we go any further. What I'm just going to do is, again, we can basically manipulate time inside of the software. So I'm going to right click and roll back above that last sketch and extrusion that I did so that I can place another feature. This one, which I'll need to sketch somewhere, and I'm not really sure how I want to do it. And it's actually clean enough that I may be able to get away with with an extrusion wizard here. Let's try it out. So I'll select all of these regions at least, and this one, and that one, and let's see if the software can build that sketch for me. It's not great. The problem might be actually the draft angle, which is what I kind of wanted to let the software figure out for me anyways. Not loving that sketch, but that's okay. If it can't build, if any of the wizards can't build geometry for you, you can always um, choose this option to maintain the sketches and exit. So it still builds reference geometry in a sketch and places it for you and lets you utilize it, but it may not be giving you something that is capable of being, like not physically possible. So it may need some editing, some tweaking. So go ahead and go into the sketch mode here. What I really want to see is like that feature there. I'm not sure where this plane lies, but if I can get the outside shape there and then just make sure we've got another circular feature that's within the body here, everything will trim together just fine. And where's that sketch? Somewhere towards the bottom. Okay, so we'll do an extrude, and when we estimated the draft in the previous step, it said 0.2 of a millimeter. That may have not been appropriate for this feature, but we can always test and find out. So we go opposite direction, up to surface. We'll say that surface. Doesn't want to do that. There's a reason it doesn't want to do that surface. That surface. There we go. So we'll put that 0.2 of a degree draft in on both sides and flip this one so that it's both going the same way, the taper. And then of course use our trusty accuracy analyzer in this mode to see how valid that is. Now, obviously I'm not really concerned about this area here because we're going to punch that out with our that sketch and extrude cut that we already created there, but I am worried about this here. It doesn't look like that draft angle is quite appropriate. So let's play around with it. And I mean, it may be that that sketch isn't ideal as well, but it looks like the more I expand this out, the less bad colors I get and the more good colors I get, which is green. So I think a degree is pretty close. And then we obviously want to not go up nearly that high. What we should be able to do, if I turn off my color map here, is there a region feature on this that might be kind of tough. Let's just roll back and see if we can build a plane. Not really any of these I like, so instead of using a region for a plane, I'm just going to manually select some of the surface here, and even my Smart Select tool is not really grabbing it, so go into real manual mode here. Quick note for those of you not aware, the Alt key when you're in paintbrush mode, plus the left mouse button on your mouse and a drag will resize your paintbrush for you on screen, which is pretty useful. So I'm happy with that amount of data. We can fit a plane there. We are not going to use the axis constraint, obviously. We built our plane, and now we're going to extrude up to it with this guy. Up to surface and that plane. And we should be able to merge that with the body, and it should look good. And there's a little bit of a dimple there, which we can punch out. And I don't know where that connects to. I have to pull the part out and take a look, but we can always add these holes in as kind of final features. So now when I roll through the end here, show my solid body, you can see that that's all looking a little bit more proper. And of course, now we can get into the actual creation of the thread. So I'm going to hide a couple of these reference geometries that I built that are no longer needed. And I'm actually going to make sure that when I built this sketch here, for a couple of reasons, I do actually want to create some construction geometry that forces that cylinder center point to be right on this front plane here. And that's because I'm going to use a sweep operation to build this feature, and the profile and the path need to be perpendicular to one another in the software. So this is kind of a cheater way or an easy way of making sure that that's the case. So I'm going to go ahead and create on that plane, which I know goes right through the axis of this part here. I'm going to create a mesh sketch, get right into it, and you can see I've got a good clean cross section of a variety of teeth. This is actually interesting because we can see really quickly that this is not a constant radius part. So didn't even notice that when I did my extrusion. I didn't really check the uh, the color map after I did that cut. So we know, and this is fairly common here. This is a gas valve part. We know that these parts are tapered threads as they screw into one another. So there is, let's see, I'll just throw a vertical line in here so we can do some measurements. There is a bit of taper that we need to account for. So I got 3.45 degrees over there. I've got a little bit less over here. I mean, this is kind of eyeballing it or just snapping lines to what are pretty close to the high points of these teeth. This is not though, so see which side, if we can get it fairly even or why we're unable to get it fairly even. That's about the high point there. So I get it any closer to the same dimension, or is that about the same as it was? About the same as it was. So 3 to 3.5 degrees of taper. There's probably some industry standard out there for, pipe applications, the taper that's associated with them. I'm not aware of that personally, so I'm just going to say 3 is probably a proper number. It's a nice whole easy number. So the first thing obviously that we need to do here, we'll keep this sketch and go back to it, but we will need to edit this extrusion with that, call it 3-degree draft. And see if the deviation looks a little bit more uniform there. Now, modifying just the draft is not actually all that useful for us since we used the silhouette function in the mesh sketch setup. And the silhouette function cannot correct for draft angle, by the way, in mesh sketch. So we need to get rid of that to estimate the draft angle, or since we already know it, um, what we can do is just basically make the smallest slice possible right on one tooth by the outermost tooth here. Center my, oops, center my cross section right on the first thread. Keep calling it a tooth because I'm used to doing gear stuff, but same difference here. So right there, a very small amount so that we're really only picking up one thread so that we make sure that this sketch is as accurate as possible. If we do draft estimation within the mesh sketch, it is going to compensate for the change of taper and never change the size of the cross section, or allegedly, if it's assuming it's working properly, which it usually does. So in this case, we want to make sure that we don't go too deep, too far away from our main sketch plane, so that the ultimate everything is as accurate as possible. So if I go into sketch mode here, now not a dramatic change in the diameter, but one that still exists nonetheless. So I can kind of grab this thing, tweak it a little bit so that it fits the majority of the profile, that inner profile there as good as it possibly can. And then what we want to be able to see as best as possible is the high point of each one of those um, individual threads as we continue all the way into the part, showing up with very high accuracy just visually that way, or minimal deviation as we proceed into the part this way. And so I'm wondering if maybe I should go to about 3.5 degrees because it looks like my deviation values are getting slightly worse as I progress through the part. So let's go back into here. We saw either 3 to 3.5 degrees of taper when we did that sketch. I may split the difference at 3.25, but let's take a look at what the accuracy analyzer gives us here. That's actually a little bit worse. So let's go back to just 3. And again, these things are, there's probably a standard out there, so we probably don't have to do all this estimation and guess and check. It's probably just better to read a table or just kind of know best practices and have that kind of tribal knowledge when you're modeling your part like this. I don't know that, so I'm kind of having to guess and use the deviation value for it here. So back into this sketch. Don't really care about the construction geometry that I have right now. That was just a really interesting thing since I was not aware that this was tapered. So now that we know that, the process really doesn't change too much. What I'm going to do is I'm going to make a sketch of something that is going to be one of my teeth cutouts. And so I'm going to put a line there and a line there and a line that is inside of the bore here. So this should be inside where the hole's already kind of cut out, but not very far. Um, and then I'll go ahead and trim everything together. I'm fairly certain I remember from 10 years ago in my engineering classes that all Acme threads are 60-degree threads, and so that's how I should design them. And I'm fairly certain after being in the 3D scanning industry for 10 years now that I can trust that these fillets here are probably not actually meant to be fillets. They're just a byproduct of how light-based 3D scanning works. And so I should make them or design them as sharp corner, teeth, obviously. Of course, I do have full design flexibility here, but the important thing is that, the angles are proper and whatnot. And so, like normal, we can come in here and smart dimension things, and that's the critical angle. So I'm really glad that I got that close to 60. These other ones I don't really care about actually, so let's forget about them. But let's force this to be exactly 60. And that's basically all we need at this point. So that is our profile that will be swept along this helix path that we're about to build. And so to build that path, we have to go into our menu, into, I think it's Insert, Modeling Feature, Helix Curve. And so the way that this tool works, I've got a plot down here. You're probably familiar with this if you've ever used the variable fillet command, which might be another video in and of itself. Um, So what I'm going to do is I'm going to select something for my axis, and that could be a vector or it could be any cylindrical or conical CAD face. We can pull a vector out of that. So I'll select that here. And then I need a starting point, which could be any point, and it's usually best to just have that be one of the points on your sketch. And when you click those two things, you're going to see this setup arrive, or a bit of a preview of what that helix is. I'm obviously not doing the cut right now, but I am generating a helix. You'll also see that there's some stuff that pops up in my plot down here. I can always use the zoom fit command if I zoom out and screw something up. And this is where we really do all of our driving of this feature. Problem is it's a little tricky to use regardless of the fact it's really tricky to use when I'm recording my screen. But you can see that, if I leave this, oh geez, each one of these nodes here is one rotation. So that's why at this point I've got 3.3 revolutions right now because I've got 1, 2, 3 and a bit there. So this is the main um, helix parameter change area that I want to try and use here. There's not a ton of options in the dialog. I do want to say that I want to extend this in the opposite direction so that this does clear the part in the opposite direction. So the main option that I have here is the ability to go X number of revolutions in the opposite direction, and it's going to take all of the rest of its value off of this. I'm going to change this to 3 degrees, but with the understanding that I don't want this part or this thing to taper up as it goes away from this main CAD face. I want it to be -3 so it actually shrinks as it goes into the part. And what we can also do is this plot mesh selection as guide, and that's just going to make sure that we're lining this up with our part here. Um, what it doesn't do, or what I'm not aware of at least, is having a good way of measuring the pitch, so the actual pitch between these two threads here, whatever that distance is, other than just the graph paper view. And I apologize for the wonky visibility again. The screen capture kind of screws that stuff up. So right now the pitch is set at zero point 0.2 inches, and that's going to be the spacing, I guess, here. So if I change this, the other thing I like to do is just have my threads on screen so I can, this is easier for me, is just making sure I'm chasing one thread all the way around. And it looks like I need about double what I've got here. So, or yeah, half as much spacing, I guess, is really what I want. So that gets me a little bit closer. And I want to make sure that as I look at this thing that I'm lining things up. So I'm actually not even quite there yet. So let's do 0.08 maybe. Maybe that's a little bit much. 0.09. That's fairly close. I'm not sure. I mean, this is probably a part designed in inches, so I know that 0.0875 is a fractional number, and that looks like it's fairly spot on. So I will need to increase the number of revolutions so that it does clear the entire part there. And I want to make sure that it terminates inside of the part as well. So that looks good. That my setup is done. And when I hit OK, we get a helix curve as an operation or a feature in the feature tree here. This is, obviously just mainly a 3D sketch, but it's parameter derived instead of spline derived. So what we'll do is now we have a path for our profile to be swept along. So we will do the sweep, and we'll choose that is our profile. This is our path. It's going to choke for a second while it renders that path. We can always turn off real-time rendering, real-time preview rather. And tough to see in this. It looks like everything goes well. Sometimes with these curves, it actually makes sense to do a path alignment type direction vector. And I always just choose the same vector that I used for my helix, and it makes sure that none of these threads like twist at all as it progresses through. It doesn't look like that was an issue this time around, but generally that's good practice. And then of course, normally I would select the cut operator here, but since I'm kind of being lazy and I want to use a mirror command rather than having to repeat this, I'm just going to say don't do anything, build it, and then Boolean cut the threads away from that body just to make sure that it works. Oops, and it does. There we go. And this is what I get, which is nice and accurate, except for the places that I don't have scan data. So I'm happy with that. Um, I do notice that the exterior looks a little weird. There's a little bit of deviation there. So as we usually do in manufacturing, we actually chamfer this before we counter or before we add the threads. So countersink, something like that. So before I do this boolean, because I have to roll back anyways, I'm going to hide the sweep for the time being. Add a chamfer, and actually I'm not even going to do that because let me go ahead and punch out this other hole first. So again, we'll use a very small amount of silhouette just to find the kind of the ID right at the front of this tapered hole. Assume it's tapered. It might not be. We actually didn't check yet. But again, we'll force this to be right on the center line. Design X 2020, we did add some new ability to snap constraints and stuff like that to the origin and make drive dimensions to it as well, which is really nice. So we'll punch that. And this one's a little bit more tricky, right? We have to figure out where this feature is going to end, and we don't really have any precedent for it other than, let me turn on some more lights here. It's really hard to see inside of this thing. Other than there's a very small, maybe it's just in my head actually. No, it is in my head. So what we're going to do is, I know that this part is centered with this center bore right on the origin here. So we're just going to extrude cut right up to this plane. And then when we cut this hole out, we know that if we center this on the origin, it's going to max out right at where it's at here. So that's a good start. We'll go ahead and mirror that body about the plane. Every time I see one of these one of these previews taking a long time, I like to try and save things. So I'm going to save right now. And let me edit this to include that. So now we got threads on both sides, but like I said, we do want to build a chamfer first. Just right click the edge there and there. Now normally I would recommend using the estimate button, but I'm not certain if it's going to be able to see the right amount of mesh here. Actually, it looks like it did a decent job. No, it's a little bit far away. Kind of eyeballing this one. Or using the accuracy analyzer to help out. Look at that, same fractional value worked again there. How's this side look? Not quite ideal. These chamfer depths are rarely dimensionally controlled though, so I'm not really going to sweat it. Let's go ahead and roll to the end. All right, so we're almost done, right? We've got the threads in. In this case, a little bit different because A, I didn't taper that extrusion, so I probably need to check that out. And B, since this is a little bit different of a feature here, it may be something where I'd want to punch a slightly larger diameter bore out so that these threads progress into the part. Again, tough to tell without actually looking at the model because all I see here are threads, but I know that this is not all thread all the way out to this surface. So I need to make some design decisions on how that's supposed to look. I also need to figure out if this actually is even tapered, which I can do really quickly here. Again, with the same method that I used before. I assume that it is. I can only assume that it is, but it's always good to get confirmation. Oh yeah, for sure. So should be about the same. Go there to there. I think that's about the high point. About there. Give me a vertical line here. And let's measure it. It's a little different. 1.435 for some reason. Oops. This one looks a little bit more like the other side, 2.6 something. So this is time where we have to kind of think about how this thing needs to be modeled. I mean, I'm trying to make this as accurate to the scan as possible in a lot of cases, or I'm trying to maybe make this more of a design intent approach. It's totally up to you. I'm not sure if that portion of that thread is quite trustworthy enough for my purposes, so that may have been why I'm getting kind of skewed numbers here. If I can do the high point on the two, only the two visible threads there, does that give me slightly different values? Yeah, it's closer to 2. The other one's closer to 2. So maybe I need to model this separately, but I'm fairly certain that these are both trying to screw onto the same type of pipe. So I'm going to leave it as it is. But what I want to do is maybe just say, I want you to thread up to a point, and then we're going to have a different diameter inside of it here. So of course, before I do anything, I do need to go take a look at that extrude that I built, and we'll add the same draft to it that we had before, which I think we used 3 degrees. So that's going to make this a little bit more uniform, right? And then what I'm going to do before we Boolean remove this, again, playing around with time manipulation here, is I'm going to just say wherever the scanner happened to see the last thread, we're just going to cut this off at that point. So I'm going to offset a plane from this face, and there's a cheap way to do that. If you hold the control key down and the left mouse button while you click a face, I'm sorry, is it the alt key? It used to be control. Oh, you can only do it to existing system planes. That's why. Okay, so I'm going to put a plane there. Again, holding the control key, left mouse button, and dragging it just does a quick create. And let's see where I need to actually put that. Somewhere maybe a little bit closer to, we'll say there, where this thing next down will end our threads. And so we'll put a new sketch on that reference plane. There's not going to be any hole in it. And so at this point, we're just going to say we'll put a circle that's there, which is the right position at least. We'll, as always, make sure the center point is on our x-axis. But in this case, we're going to make this a smaller diameter. So this would be something where I'd have to use some hand tools. I don't have the part on me right now, so I can't use any hand tools. But if I do build this, I actually want this to be bigger than the hole that I have. So that my threads kind of terminate where it begins here. And so that might be fine. And we'll again end it at this plane. let this roll forward so that it does cut the threads out and see how that looks. So now they kind of have a clean termination inside of the part here. And the last thing that we do is, of course, cut out the center bore of this thing, which is pretty straightforward. Although this may be tapered again, actually. So um, if I shrink down my bounding box so that I'm only looking at, especially if I'm only looking at the majority of this feature on the inside and nothing else, there, try and get rid of as much other cross section as I can. That's going to make sure that the estimate draft angle tool works properly. There's no other stuff in there. And it's saying I got about a degree of draft. So I'm going to say that there's about a degree of draft here. 0.8954 is as close to 1 as I need it to be for the draft angle estimator. So build my circle here. And I'm going to extrude down to this surface, which actually is not going to let me do that, and that's fine. There's another way we can do this too. I'll just go blind. We'll go way, way into the part, and we'll just cut away what we don't want later. Not do a cut, but definitely add that same draft, which in this case was just 1 degree. Again, now I've got another solid body here. So if I can't make it extrude to where I want it to go, that's fine. What we can do is just say I want to do a, actually I can even take that same sketch that I did before. This might be an easier way of doing things. And instead of doing a solid extrude, I'll just do a surface extrude this time. Same taper. Make sure it passes all the way through that feature that I'm trying to intersect with it. And then in this case, I just want to trim the surface body with a new plane. So, oops, I want to keep the bottom part. Excuse me. And now I can extrude up to that, or now I can actually cut my other body. That, this, keeping this, Boolean removing that from this. Let's see if I did it right. Pretty close. Looks like when we did that revolve, we still didn't bring this all the way down to the bottom here. So there's still a little bit of an issue that I need to worry about. And then I need to add some fillets in here because there is really no blend that happens. If you look at the part that we have, there is actually a little bit of a notch there. So adding, rather large radius fillet here and here, and I won't want to do that in the same operation. But this is basically how the part looks in real life, is it's just milled out with a certain radius end mill to cut this out here. So do need to do a little bit of cleanup here, but that's a minor operation. I'm going to go ahead and end the video because it's over an hour long at this point. And really hope that you found this interesting, found it informative, learned something. Let me know in the comments if there's anything that I missed or that you didn't understand about this, or if you've got any topic suggestions that you'd like me to cover in the future. But until then, thank you very much for watching.